So I first became interested in blockchains when somebody pointed me to a paper that claimed that they had a Byzantine consensus algorithm that was being used as the foundations for a company.
This is Maurice Herlihy, a professor at Brown University who visited EPFL a few weeks ago. Herlihy is one of the world's leading experts in distributed computing. But like many other researchers, blockchain has piqued his curiosity.
Now, this company had raised something like $20 million, and they published a white paper on their consensus algorithm. And after reading the first half of the first page, it was clear that this protocol was wrong, that it couldn't possibly be correct. It was clearly put together by well-funded amateurs. So sure enough, the protocol did fail. This company then had serious technical problems. They used this as a reason to raise even more money to fix their problems. So it worked out well for them. But what I learned from this is that a lot of the work on blockchains started with some very creative ideas about how to reach agreement in a very hostile environment. But a lot of it is reinventing notions that have been around in the distributed computing research community for a long time. These notions weren't always reinvented correctly. There's a lack of rigor and formal methods, which is kind of alarming since these programs are managing hundreds of millions of dollars. And indeed, every morning when I wake up, you look at the newspaper and somebody has stolen another 30 or 40 million from someone else because of poor algorithm design, poor language design, all kinds of things that I think a more rigorous approach would have been avoided. So I think this is a great opportunity to apply the principles of distributed computing to an exciting new application area. And I think the benefit both to the practitioners of cryptocurrency in the sense that they will have algorithms that are much secure and efficient, and the benefit to the research community in that we have an application that the world at large cares about. I think there's a lot of mutual advantage to pursuing this.
Now, this is not to say that blockchain is not a major breakthrough.
The blockchain community is extremely innovative. So it's sad but true that often real innovation in research community starts from outside the community. So blockchain was not invented by distributed computing people. My claim is that distributed computing people can fix it. But if one of us had written, say, the Bitcoin paper in 2008 and submitted it to a conference, it probably would not have been accepted because it didn't have any proofs. It was vague about many things. It didn't follow the cultural signifiers that one would expect from an academic paper. And yet it was far more innovative than most of the research papers that were published at the time. So I think we should be thankful that we have such a great application area where we can apply all of the algorithms and the techniques and the approaches that we've developed before. But left to ourselves, we never would have invented Bitcoin. All that we can do is say, hey, what you're doing over here is something that we actually know how to do. And why don't you listen to us and read some papers before you do something dangerous.
So what are the challenges posed by blockchain that classical distributed computing can help with?
I think there are very many open questions. I think the main question at the heart of a lot of the blockchain work is that blockchain is based on this vision that one can radically transform how trust works in modern society through the use of blockchains. But what we see in modern blockchain work is that a lot of it is extremely untrustworthy. The number of thefts and hacks and so on is extremely high because, in principle, everyone can agree on the meaning of a smart contract. Everyone can agree on the meaning of a Bitcoin transaction. In practice, we still don't know how to write correct code.
We briefly talked about smart contracts in a previous video. Typically, you can write a small code in the blockchain that will be automatically run by the miners. Crucially, such a code can serve as a contract For instance, of the form of, if you give me that amount of money, then I will give you access to my house for the New Year's Eve weekend. Now, the thing is that codes are automatically run even when they are poorly written. This is what happened in 2016 when a bug in a smart contract code written on the Ethereum blockchain led to the loss of $50 million. This led to a huge mess with complicated stuffs like the attempts of a hard fork.
The people who make these mistakes that lead to these large security breaches are typically very talented, very accomplished programmers. And if even they can't get it right, then there's something that needs to be fixed at the heart of this world. So I think the challenge is how can we actually write correct and verifiably correct distributed algorithms that manage money and valuable assets in a very hostile environment where every hacker in the world is working hard to figure out how to break your security. So this is something that in principle we've talked about Byzantine failures and fault tolerance and so on. But this time we get to try our ideas out for real. And if you fail, then somebody's going to empty your bank account.
Now, apart from the provable safety of codes, blockchain research is full of major technological challenges.
Everyone in this area is interested in how to implement scalable blockchains. Current blockchains are much too slow to realize their promise. And I think nearly everyone who's working on this has some ideas about alternatives to current proof of work or proof of stake algorithms that will be both secure and scalable, that will protect privacy and do all of these other things.
But perhaps the most important of all is to guarantee more than ever the reliability of the blockchain. This reliability has the potential of dramatically changing the world we live in.
I think the other major challenge is that in some sense cryptocurrency is perhaps not the most important application of blockchain. Blockchains can also be used, for example, to fight corruption in countries where it's difficult to get access to public records. I think Costa Rica now has all of their property records on a blockchain, so that if you're a poor farmer and you want to prove that you own your land, you don't have to pay bribes to the local bureaucrat. You don't have to worry that some rich person is going to forge documents. There are also things like logistics, making sure that being able to track every stake, so that if there's an outbreak of disease, you know exactly which animals your food came from. Logistics, if my shipment of ice cream is melted when it shows up, I can figure out exactly where along the the sequence of transmission something went wrong. So I think the effect on everyday life is going to be far more pervasive than the current cryptocurrency bubbles, which are very dramatic and they dominate the newspapers. But in terms of the long-term effect on society, I think these other applications are going to be far more effective, even if they're not quite as sensational. So the big idea number one is that we're going to allow the miners to discover a safe, serializable concurrent schedule. Distributed computing is a very broad field which encompasses many different areas.